Hello, welcome to lecture 40 of game theory course. We have just entered the week 14, which is supposed to be the final week of the course. We may just a little bit deep into week 15 if we do not have enough time, but probably we will. So let's wait and see. We are almost at the end of the semester. Okay. So common in PBE. What does that mean? I told you there are separating equilibrium, pooling equilibrium, and hybrid. Okay? And each of those equilibrium, we should wrote down 9 things. However, I'm going to explain and you will soon understand there are 5 things would be common regardless of whether it is separating, pooling, hybrid. So I'm going to write that first because these 5 things will stay the same whether it is separating, pooling, and hybrid. Common in all PBEs, or 3 PBEs. North Korea, insane, T2. Fight. Okay, let's go back. North Korea, insane North Korea, if fight 2, surrender negative 2. Basically, North Korea, insane North Korea, always fight. Whether it's T1 and T2, it'll get 2 instead of negative. Otherwise, negative 2. So, no reason not to fight. That's why North Korea, insane, T1 and T2, 1 and 2, fight. After all, they are insane. They enjoy fighting. They want the USA attack them, and they are gonna fight USA and would be defeated and killed, but still they are happy. That is the proof of insanity if they feel really that way. What about North Korea who's sane? Sane North Korea always want to surrender, okay? Because surrendering gives them negative 2, but negative 2, the blue one, but I told you x is bigger than 2, which means x, negative 3, negative 4, negative 5, whatever, negative 2 is better than negative x because x is bigger than 2. Why do you want to get killed? You just surrender, humiliated. I would be happy to be humiliated rather than being killed at a gunpoint. So if North Korea is like me, they will surrender. Okay? However, we know that in T1, the North Korea would rather choose minus x than minus 2, even though minus x is worse, because it may have a hope. If I fought USA in T1, USA may misunderstand me as a crazy type, insane type, so in T2, USA may not invade me. So instead of getting negative 2, I may get negative x, which is worse than negative 2, but then 0. If x is 3, negative 3 and 0 is better than negative 2, negative 2. It's negative 3 against negative 4. So, in T1, North Korea may have the incentive to fight in order to pretend to be the insane type, even though it's sane. What about T2? It's the final stage. Do you have any reason to pretend to be something else when there's no future? You pretend to be a nice boy in order to get a date with a girl in the future. Something like that. So when people pretend to be something else, they want to give a first impression and exploit the benefit out of it in the future. So pretension is sacrificing today in order to get a bigger thing in the future, right? Like you hate study, but you pretend to be I love study, I'm very smart kind of thing before you enter university. But then after enter university, you don't have to pretend anymore. If this is the last day of university, you don't have to pretend to be something else because you never meet these people anymore. So, what I mean is, saying North Korea in T2 final stage doesn't have to pretend something else anymore. It definitely prefer surrendering and getting -2 more than fight. So, the North Korea in second stage, T2 always surrender if it's sane. Different from T2, T1. What about USA in T2? This parenthesis means after observing North Korea, why there's no INS, USA's point of view, it does not know whether North Korea is sane or insane. It just knows that, I don't know whether it's insane or insane, but definitely North Korea surrendered in T1. That has something to do with number 5. Mu is the belief that North Korea to be sane. It's probability North Korea to be sane, like subjective. When the USA, of course, this belief is the beliefs of USA because North Korea definitely knows whether itself is sane or crazy. North Korea surrenders in T1. Would it be sane? Yes. Why? I mean, the crazy North Korea would never surrender. It loves fight. Fight most. I mean, when you can do something you like most, why don't you do it? You want to do it over and over again. So North Korea will definitely fight if it's insane, whether it's T1 and T2. And if you observe North Korea surrendered in T1, you know that the insane, crazy North Korea never surrender, which means North Korea is definitely, with probability 1, sane. Okay? Knowing that if North Korea surrenders in T1 and USA knows that North Korea is sane, then what? If you attack, you know North Korea will surrender again, you will get 1. If you don't attack, you will get 0. 0 and 1, 1 is better. That is why the USA, when it observed that North Korea surrendered in T1, then in T2, USA will attack North Korea and get 1. Because North Korea will definitely surrender, as we saw in line 3. Okay? So these things is for sure whether we are dealing with separating, pooling, or hybrid. What is changing is the next 4 things. Let's assume that x is 5 and p equals 0.3. P means the probability that North Korea is insane, crazy, which automatically means North Korea is sane, normal, with a probability of 0.7. So now, the sane North Korea, if surrender, gets -2, fight gets -5, and for North Korea to be sane, it's 0.7 probability. Okay? Here, I mean, how can you, with this number, how can you know whether the game is separating, pooling, or hybrid? The answer is you don't. And how can you find out? You try all 3 of them. So when you have a game like this, okay, and like x is -5, 1 minus p is 0.7, p is 0.3, you have this game. Even me, most of the no game theorists would immediately know whether this game has separating equilibrium, pooling equilibrium, hybrid. How do we do that? You just assume that this game has separating equilibrium. And you look at that. And if you find out something contradictory in the middle of the process, you said, oh my God, this game does not have separating equilibrium. Then you move to pooling, you check, and you found out something contradicts. Okay, this game does not have pooling equilibrium. Then the chances are this game has hybrid. Of course, it would be much better if you just try the hybrid first, but you never know whether this game is hybrid, pooling, or separating. If you are unlucky, you try hybrid, you try pooling, both fails. Now you realize separating, you waste your time. You just try pooling, oh, it has a pooling, you're a lucky guy, you don't have to try the separating and hybrid if you're asked to find out one equilibrium kind of thing. Okay, so how do we find out? Let's check separating. If it's separating, the same North Korea and T1 should choose surrender. Why? Separating means different types, different action. The insane North Korea and T1 fight. So insane type choose the action of fighting. So the same type in T1 choose the action of surrender. Why? We assume that this one has separating equilibrium. So let's just assume the number 6. Later we are gonna check whether this number 6 can be vindicated, justified by the other. But let's begin with this assumption. If this is the case, the belief that the North Korea is sane when North Korea fight in T1. Because we know that the insane North Korea will always fight, the sane North Korea will always surrender. So when you see North Korea fight in T1, North Korea must be insane, must be crazy. So the belief that North Korea is sane would be 0. Understand? We already saw if North Korea surrender, then North Korea is definitely sane. That is not the same thing as this. This sane North Korea may surrender or may it can randomize between surrendering and fight. Then even though the surrendering guarantees the sanity of North Korea, but fight does not guarantee, because sane North Korea surrender with 50% and fight with 50%, then this would be not 0. But then, because we assumed a separating equilibrium, we decide to check whether this is separating equilibrium, and we are checking it. North Korea in separating equilibrium will surrender in T1. Then the belief should be from 6, we can get 7. North Korea fight. It's never be sane. It must be crazy, because sane North Korea already surrender. So when USA watched North Korea observed fight in T1, for sure by 7, this is crazy guy. The sane with probability 0 means insane with probability 1. So instead of going in and getting -1, because this insane North Korea will definitely fight in T1, USA will stay out, status quo, and get 0. Okay? What about all this backward induction? I mean, knowing all this, at the start, what USA will do in T1? Okay? From 8. Okay. Oh, before that, this 8 can justify 6. 6 was assumed because we assume a separating equilibrium. But from sane North Korea's view, if it surrenders, then what would it get? -2, -2. See? US attack, surrender, -2. because North Korea surrendered, USA immediately know that North Korea is sane. So attack again in T2 and surrender again. So -2, -2. On the other hand, inside the separating equilibrium, the US attack, the insane North Korea will fight. So insane North Korea fight, USA will know it's insane, so status quo. So the same North Korea is supposed to act in the separating area, attack, surrender, attack, surrender. Insane, USA attack, fight, status quo. So the North Korea may be wondering, oh, okay, if I, instead of getting -2, if I get -x in T1, then I'll get 0. So I should compare -2 against -x plus 0. What about that? Because x is 5, -5, 0 is -5. On the other hand, surrender is -4. -4 is bigger than -5. Okay? That's why the North Korea, sane North Korea surrender in T1. Okay? So, even though the 8 is true, the 6 North Korea would surrender. So even though we start from assuming the North Korea saying surrender, finally it makes sense. Okay, even though the USA will never attack you when you fight, the first period damage is so big, the North Korea has no intention and incentive to it. So this is not assumption anymore. This is the best behavior of North Korea. What about USA in T1? If USA choose to status quo, the promise is once USA choose status quo in T1, T2 it should be status quo. Why? If USA in T2 attack, then it'll be like T2, T3 game. Okay, attack twice and in the future. So, I mean, we assume that whenever it's attack, it's the first period. If USA do not attack, it will stay do not attack forever. So, if USA stays quo, it will get 0 in T1 and 0 in T2. USA attack, two things can happen. North Korea might be sane and surrender. Attack, surrender, attack, surrender if North Korea is sane with probability of 70% because P is 30%, 1 minus P is 70%. If North Korea is insane, US attack with 30% chance, North Korea fight and US will get -1. What will US do? Stay out, status quo. So it's either 70% of chance if US attack in T1, 1 and 1. Because North Korea is sane, 70%, 1 plus 1. North Korea may be crazy with 30% attack, -1 and 0. Let's write it down. North Korea may be insane. I wrote it wrong again. This is, okay, I'm sorry. This is should be -1 plus 0, and this is 1 plus 1. Sorry on that. 1 plus 1, -1, 0. So it's going to be 0.3 multiply -1, 0.7 multiply 2. So 1.4 minus 0.3, which would be 0.9, I think. 1.1, which is bigger than 1. Okay, sorry for the miscalculation once again. It's 0.3, -1 plus 0, because US, it's US payoff. 0.3 multiply -1 plus 0, 0.7, 1 plus 1. The right hand side in my calculation is 1.1, which is bigger than 0. So US status quo in T1 would give 0. Attack would give 1.1. That's why USA will attack. Okay, so this is separating equilibrium. So luckily, we check separating equilibrium when x is 5 and p is 0.3. You write down number 1, 2, 3, 4, 5 automatically, and 6, 7, 8, 9 because it's separating equilibrium. Then you have successfully find the perfect Bayesian equilibrium of the game. Okay? Good. So maybe you have noticed this payoff x and the probability p is playing very important role, because if we change x to 3 and p to 0.6 instead of 0.7, I'm going to show you we are going to have a pooling equilibrium instead of separating equilibrium. Once again, let's check whether this is separating equilibrium with this number. I'm going to show you this is not. Because separating equilibrium, okay, this North Korea in T1 should surrender. Okay, let's check whether it's separating. So instead of fighting, we'll assume North Korea in T1 surrender. Then North Korea fight, probability North Korea is same. So for x equal 3, p equal 0.6. Let's see whether this is true or not. This will surrender by assumption. US saying when North Korea fight would be 0. North Korea might be crazy. The USA, would it fight here? No, because North Korea fight, then if it's sure, then North Korea will fight again. If US attack in T2, it will get -1. Okay, here. If North Korea is crazy, US attack, North Korea fight. Oh my God, if I attack again, it will be -1 again. So it's just status quo. However, as soon as USA would do that, it does not justify the first line, North Korea will surrender. North Korea would be thinking, okay, if I surrender, it's -2 to -2. However, now I know that US will not fight, choose status quo instead of attack us. If I fight in the first period, I'm getting -3 instead of -5 because it has changed. Okay, we are checking when x is 3. So if x is 3, North Korea would be thinking -3 plus 0, -3 is bigger than -4. So why am I surrendering? If I fight, then I'll get -3 instead of -2. But USA, because I fight, will not attack. It will choose status quo. Therefore, I'll get 0. So if x is 3, the 6 cannot be vindicated. North Korea has good reason not to surrender in T1 if 7 and 8 are true. That is what I mean contradiction. So when x equals 3 and we are checking separating equilibrium, the starting point, North Korea saying North Korea will surrender, and as a result, 7 and 8 holds. When 7 and 8 holds, immediately we know that the 6 does not make sense, because by not surrendering and fight, saying North Korea would get -3 plus 0 instead of surrender -2 -2. That's why saying North Korea will not surrender and fight. Okay? That is why if you face x equals 3, p equals 0.6, and you decide checking the separating equilibrium, and then you would find out a contradiction in your equilibrium, because the saying North Korea in T1 in separating equilibrium should surrender, but it wouldn't, because -3 is better than -2, -2, -4. Okay? So here, no. So now we are going to check whether this is a pulling equilibrium in the next class. This has been the lecture 40 of game theory course, and I will see you in lecture 41 next class. Thank you.